Hi, here we have let n be any natural number such that this inequality is true, then the least integer value of m that satisfies the inequality for each n. It should be satisfying for each n, not just 1 or 2n, for each n. Okay, so let's first figure out what are the values that n can take. So if we take n equals to 1 in this case, see, generally we know a power of 5 should be greater than power of 3, but same power. But since here the powers are not same, so we'll have to check for which value of n this will be true. So if we take n 1, this will become 5 to the power 0 and this will become 3 to the power 2. Obviously 3 to the power 2 is greater than 5 to the power 0. So n equals to 1 is acceptable. N can only be natural numbers, right? So this value of n1 is possible. What if n is 2? So the left hand side becomes 5 to the power 1, the right hand side becomes 3 to the power 3. So this is 27, which is definitely greater than 5. So this is also acceptable. What if we take n3? This becomes 5 to the power 2 and this becomes 3 to the power 4. So this is 81 and this is 25. Still 3 to the power 4 is greater than 5 square. This is acceptable. Then you take n4, this becomes 5 cube and this becomes 3 to the power 5. Now 5 cube is 125 and 3 to the power 5 is 243. So this is still greater. So this is acceptable. Then you take n equals to 5. So this becomes 5 to the power 4 and this becomes 3 to the power 6. 5 to the power 4 is 625 and 3 power 6 is 729. So still this is greater. This is acceptable. What if you take n6? Then you have 5 to the power 5 and this is 3 to the power 7. Now 5 to the power 5 is 3125 and 3 to the power 7 is 729 into 3. So this will somewhere come out to be 2200. Now the right hand side is not greater than the left hand side. So this will not be accepted. And if you further go ahead for higher values of n, the left hand side is increasing at a greater speed. See, it's getting multiplied with 5. For every increase of n, the left hand side is getting multiplied with 5 and the right hand side is getting multiplied with 3. So left hand side is increasing faster than the right hand side. So if left hand side is already greater in this case, for further values of n, the left hand side will be always greater than the right hand side. So we get only these 5 possible values where the left hand side is less than the right hand side. Okay, these are the 5 values that n can take. And now let's check the other inequality. So now we have to figure out the least integral value of m that satisfies this inequality for each n. Okay, so let's start with the first case. So we have 3 to the power, here n is 1. So 3 to the power 2, which is 9, should be less than 2 to the power 1 plus m. So the least value of m here in this case comes out to be, see, some power of 2 should be greater than 9. So what is the least power of 2 greater than 9? 2 to the power 4. So this should be equal to 4. 1 plus m should be 4. So m least is 3 in this case. So the least value of m can take is 3. So m can take values of 3, 4, 5, 6 and so on, and that will satisfy this inequality when n is 1. In the second case, we get 3 to the power 2 plus 1 when n is 2. So the left hand side becomes 2 plus 1, which is 3 cube. 3 cube is 27. This should be less than 2 to the power 2 plus m. Okay, n is 2. So what is the least power of 2 that will be greater than 27? The least power of 2 greater than 27 will be 5 here. So from here, the least possible value of m will come out to be 4, right? 2 plus m is 5, sorry, this will come out to be 3 itself. 2 plus m should be 5. 2 power 5 is 32, which is greater than 27. So the least value of m comes out to be 3. What about this case? This will become 3 to the power 4, which is 81. This should be less than 2 to the power 3 plus m. So what is the least power of 2 which is greater than 81? 2 to the power 7. So this should be 7. 3 plus m should be 7. 2 power 6 is 64, which is less than 81. then 2 power 7 is 128, which is greater than 81. So 3 plus m should be 7. So the least possible value of m will come out to be 4 from this case. Fine. In the next case, we have 3 to the power 5. N is 4, so 4 plus 1 is 5. 3 to the power 5 is 243. This should be less than 2 to the power 4 plus m. Now what is the least power of 2 which is greater than 243? The least power is 8, 256. 2 power 8 is 256, right? 2 power 7 is 128, which is less than 243, so that would not work. So we take 2 power 8, which is 256, greater than 243. So 4 plus m should be 8. So the least value that m can take is 4. M can take higher values as well, but this is the least possible value. And coming to the last case, we have 3 to the power 6 is 729. This should be less than 2 to the power 5 plus n. Now what is the least power of 2 which is greater than 729? The least power is 10. 2 power 9 is 512, not greater than this. So we take 2 power 10, which is 1024. So the least possible value that m can take over here is, if 5 plus m is 10, the least possible value of m is 5. Okay. Now considering all these cases, what is the least possible value of m which satisfies this inequality for all possible values of n? The least possible value will be the highest of this. The least possible value of m is 5. See, if you say the least possible value is 3, 3 will satisfy this case and this case, but in these cases this will not be satisfied, right? But we want to satisfy all the possible cases, right? We want to figure out value of m which will satisfy for any value of n. So for any value of n, the least possible value will be 5. In this case, m can be 3, 4, 5, anything so on. Here also 3, 4, 5, anything so on. Here 4, 5, 6, 7. Here also 4, 5, 6, 7. Here 5, 6, 7, 8. So considering all these cases, the least value of m satisfying all these cases will be 5. So the answer to this question is 5. Thank you.